Today we're going to make a power supply capacity tester for the L3HARRIS PS-855 series jet power supplies. The vendor manual does not have a discharge device for this. They just tell you to acquire a 7 ohm 1% tolerance resistor that's at least 150 watts, connected across the two output pins, the plus and minus of the power pack, connect a voltmeter to the plus and minus, and discharge that power supply for either 20 minutes or 48 minutes. To do all of that simultaneously and to have people manually plugging pins on the back of the power supply, you could be asking for trouble. Those power supplies run $6,000 brand new. So this is a very easy device that will allow you to monitor the output voltage with a voltmeter, turn on a switch and start a timer all simultaneously with no interaction of having to pin pins to the back of the power supply. This is very easy to make, although not inexpensive. The most expensive component to this whole setup is the connector that interfaces to the back of the PS-855. You don't need this. You could actually plug the wires in manually to the back of the unit, but this Murphy proofs everything. And this runs about $300 by itself. The rest of the components for this entire setup is only $200 to $250. Okay, we'll show you how simple this is and what you're going to need. You need a die-cast aluminum enclosure. This enclosure with the lid by itself weighs about 3.5 pounds, and you're going to need something with some weight because it has to sink the heat of the resistor. This is the connector. You can either use this or not. You can use 2 wires or you can use a connector. The connector Murphy proofs the entire operation. This is the 7 ohm plus or minus 1%, 250 watt resistor. This is the power hungry component. You got the mounting hardware for the resistor. You got the mounting hardware for the plug. You've got your tip jack for positive meter lead, tip jack test point for your negative meter lead, LED to let you know this is on, a resistor to go in series with that LED, 5 amp circuit breaker just to keep yourself protected. But that resistor with the 24, 25 volts, you're probably going to draw maybe 3.84 amperes. Single pole, single throw or single pole double throw switch, it doesn't matter, as long as you can open and close the circuit. And I prefer to use a switch guard to make sure that switch is off when you plug this box onto your power supply. Heat shrink for the solder connections. 20 gauge wire and assorted 20 gauge lugs to fit all the components you're putting in the box. And a tube of heat sink grease, because we're going to coat the bottom of this resistor with the grease and securely mount that to the enclosure to make sure we heat sink this thing correctly. Okay, let's put this stuff together. These are the components placed in the box, ready to get wired. You've got the connector that will slide into the back of the PS-855. Got the 7 ohm resistor. Got the switch with the guard. Up through here, you got the 2 test jacks, the LED, circuit breaker, and a 3300 ohm resistor for the LED. All right, we'll wire this up. And I don't have a power supply here, but I got a 9-volt battery we can plug into this connector and give it an operational test. This is the finished product, 7 ohm resistor. We got the heat sink grease in there and it's squeezed out really nice. So it is definitely conductive for heat. We got the connector. There's our 3300 ohm resistor for the LED, switch, test points, LED, circuit breaker. Let's try it. Got a 9-volt battery hooked to the input of the box where that PS-855 would be. I've got no volts on the meter. Circuit breaker's out. We're going to put the circuit breaker in, and this will give us the open circuit voltage of that 9-volt battery. So we got 8.72. And now we're going to turn on the discharge unit. Oh, we're killing that battery. It's not going to last long. Got the LED, got your discharge cycle. You would have started your timer when you turn the switch on. This was super simple to make. I don't know why you can't buy one. This is the finished product. Put a nylon webbing strap on this because this gets hot. I only deal with the 855 Deltas. They test for 20 minutes. If you had to work with a Bravo, those have to go 48 minutes. I can't imagine how hot this would get with a 48-minute discharge. Why L3 or Harris does not manufacture something like this is beyond me. This is easy and this is Murphy proof. This box in its entirety if you had to purchase this connector, $700. Why L3HARRIS does not manufacture a capacity tester for their equipment is beyond me, because this is easy. And they can make a killing on these boxes. I made this to Murphy-proof our process. If you get individual employees trying to stick individual wires into the back of that $6,000 power supply, you're asking for trouble. This will connect properly 100% of the time. You can't mess it up. So I don't know why nobody manufactures these, but it's going to make our life a lot easier. Thanks for watching.